we will start the discussion of the properties of the cumulative distribution function. Already we have defined what is cumulative distribution function, joint cumulative distribution function of a bivariate random variable. So, you may, so this is here we discussed. So, this is for two random variables x and y, both are random variable from a sample space. It is a x is a function, not only that it is a measurable function from S to R, and y is also a measurable function from S to R, and we define x y, this is a measurable function from S to R defined by for any S belongs to S, x y of S, this is nothing but f x y of, so x y of S, this is nothing but x s and y s. So, both are a real number because this is also a measurable function, x s this belongs to real number, y s this is also belongs to a real number. So, this is nothing but in R 2. So, x y is a measurable function from S to R 2. So, this is a bivariate random variable we already discussed, and then we defined the joint probability distribution function, the joint C.D.F. joint cumulative distribution function C.D.F. joint C.D.F. of the random variable x y is defined by f x y which is nothing but x less than equal to x, y less than equal to y for all x y belongs to real number, or we can say for all this x y belongs to R 2. Now, we have already defined what was those things. So, we denote A x is the event x less than equal to x, which is nothing but all s belongs to S such that x of s less than equal to x, and B y is the event for given x, for x belongs to real number, x is this, and for y belongs to real number, B y is nothing but y less than equal to y, which is nothing but all s belongs to S such that y of s less than equal to y. So, this is a subset of S, this is a subset of S, then A x intersection B y, this will be a subset of S. Not only that, because x and y are measurable function. So, A x also in the sigma field and B y also sigma field class of event that we consider here, and then A x intersection B y, because it is a sigma field, it should be inside C. So, it will be a subset of S. Then we can talk about the probability of A x intersection B y, that is the probability actually here. So, this is nothing but probability A x intersection B y, this probability it is discussed. Now, we will discuss some of the properties of this random variable, properties of this cumulative distribution function. This cumulative function, this function is defined. Since there is a probability, so it is very clear that because f x y of x y is a, it is giving a probability. So, this must be belongs to 0 and 1. And next property is that x 1 is less than equal to x 2 and y 1 less than equal to y 2. Then let us discuss first, if 2 points in the real line you are taking, x 1 is less than x 2 or equal to, you can consider, and y 1 is less than y 2, then so y 1 less than equal to y 2, then f x y of x 1 y 1, this should be less than equal to f x y of x 2 y 1, this is less than equal to f x y of x 2 y 2. So, any of these inequality you can see that we are fixing y 1 here, one coordinate it is fixed and one coordinate it may be increased. So, let us prove this. So, how? So, similarly we can prove that. So, x 1 and y 1, so f x y of x y and y 1. So, what is this? So, this is nothing but probability that x 1 less than equal to x 1 intersection, basically this is nothing but y1 sorry y1 1 minute x less than equal to x1 and y less than equal to y1. So, this is the probability by definition. So, now this is nothing but we know this is event x1 intersection y less than equal to y1, this event. Now, what is fxy of x2 y1? This is nothing but probability that x less than equal to x2 comma y less than equal to y1. This is nothing but probability that x less than equal to x2 intersection y less than equal to y1. So, now what is the relation with this? See, both the cases you can see that, suppose if we write this is probability of ax1 intersection by1 and this is nothing but probability that ax2 intersection by1. Now, what is the relation with this weight? Now, since x1 is less than x2, then we have already shown that ax1 will be subset of ax2. If it is equal, then this two set will be equal, but if it is strictly less than, then if any element belongs to ax1, that means this is satisfying this relation x less than equal to x1, sorry ax1 means, so any element suppose s is belongs to ax1, that means x of s is less than equal to x1 by definition of ax1. Now, since this is less than equal to x2, which implies x of x less than equal to x2, which implies s belongs to ax2, because this is the definition of ax2, that all x satisfying x is less than equal to x2. Hence, ax1 is subset of ax2. Now, if you take any intersection of same set actually, because we are taking, so now ax1 is subset of ax2 implies if you take intersection same set both side, so then ax2 intersection by1, because it is by1, because this is ax1 is subset of ax2, take the intersection both side. Basically, if you write suppose this is s, this is ax1 and this is ax2 will be the superset. So, that means here ax1 it is and then this is the bigger set is ax2. Now, this is the ax2. Now, if you take by1, 1 minute. So, suppose this is ax2 and this is, let us draw a bigger graph. So, suppose 1 minute. So, this is the sample space is, suppose this is ax2 and this is inside here ax1, this is ax2 and then by1 is suppose this. Now, the subset of ax1 intersection by1, so this is nothing but by1. So, by1 intersection ax1 is this part and by1 intersection ax2 will be whole part. So, that means ax1 intersection by1 will be subset of this part will be subset of ax2 intersection by1. So, that is so which implies that probability that ax1 intersection by1 this will be less than equal to probability of ax2 intersection by1. So, that actually here this is the probability, this is the, hence from there we can conclude that fxy of x1 y1 will be less than equal to fxy of x2 y1. Similarly, you can show that very similarly we can just keep x2 fixed and then you increase the value of this second coordinate, then it will be less than equal to. Similarly, another this relationship will be same x1 y1, here we first fixed y1, here we fix x1, then fxy of then x1 y2 which is less than equal to fxy of x2 y2. So, this is the relationship. So, both this proof will be very similarly you can show it. So, now these are the some of the basic properties and now this is the another properties that if you take x goes to infinity, y goes to infinity, fxy of xy, this is nothing but fxy of infinity. It is not we are putting this value, it is just a value, what is the limiting value that we want to find. So, how actually we will not go the rigorous proof, we just try to find the some intuition. So, what is fxy of like x y. So, this is nothing but probability that x less than equal to x, y less than equal to y. Now, if you tending limit x goes to infinity, what will be this set? Because x goes to infinity, this small x, it is that means it is like equivalent to say that x less than infinity. So, now it will satisfy all the. So, basically x is a random variable, it is a measurable function from s to r. So, it will all s, it will satisfy this relationship if you take x tending to infinity. So, this is nothing but whole s. Similarly, if you take y goes to infinity, y less than equal to y, this is also whole s. So, hence limit x goes to infinity, y goes to infinity, f x y of x y, it is does not that is just equal to, just from this concept we can say that this is nothing but probability that s intersection s, which is probability of s, which is nothing but 1. So, this is actually it is coming. Now, in case of, so if you take limit of x goes to minus infinity, suppose if you consider limit one of the variable minus infinity f x y, what will be the value x f x y. So, now this is nothing but limit x goes to minus infinity, probability that x less than equal to x, comma y less than equal to y. So, now just from the just we try to understand it how what should be the value. So, the proof will be different, but just we are trying to understand here. So, when x goes to minus infinity, what will be this event? Limit x goes to minus infinity. So, what will be? Because x is a function from s to r. So, assuming that this is inside all the values. So, here x less than equal to x, this function is nothing but all s belongs to s, such that x is less than equal to x. Now, if you tend small x goes to minus infinity, so there will be none of the value will be in s satisfying this relationship. So, this will be nothing but it will be empty set. So, now the proof actually exactly if you want to prove that will be different, but it is just to understand it. So, now if this is empty set, so then this is nothing but this probability will be nothing but probability that phi intersection y less than equal to y. So, whatever the set y less than equal to y be with this intersection with a null set. So, this will be nothing but again a null set. So, this is nothing but this is equal to it will be 0. So, and similarly you can show that limit y goes to infinity, y goes to one of the coordinate component of this vector, if you take minus infinity, if you take y goes to minus infinity, f x y of x y, one of the component if you goes to tend to y goes to minus infinity, this will be again equal to 0. So, this is some of the properties, just try to understand it only. So, now this will be a right continuous function, we are not going to prove it, just to understand it. So, basically for univariate cases also we have checked that it is function will be right continuous. So, right continuous means if you take the limit like f x y, suppose if you take the limit, so age is positive decreasing to 0 or so age tending to 0, that means positive value age, and if you are taking suppose a plus age, a plus age a plus age y, any value y. So, this is nothing but this limit, it is called the positive limit f x y of a plus y. Now, this value may or may not be equal to. So, if it is equal to exactly the value a y, so this limit, if this is called a right continuous, this function is right continuous, right continuous. So, this is a, so similarly it is for other coordinate also we can show that x y plus a b plus, so some value b, this is nothing but actually limit, we can write limit. Similarly, we can write that limit h tending to 0 f x y of x b plus h. So, h is positive number tending to 0, this is nothing but it is defined as a x b plus, this will be is equal to f x y of x b. So, this is the definition of a right continuous. So, both the coordinates it is right continuous. So, both the components the f x y is a right continuous function. Now, what about other properties? So, this is right continuous, that is it is written here b plus equal to f x y b. So, these are usual it is you have already seen this kind of properties in univariate cases also, univariate random variable cases also we have already discussed these properties. Now, we will discuss some of the more properties. This property is also equivalent, it is just straightforward extension of the univariate random variable. So, now second sixth property it is saying that if you consider how we will find this probability y less than equal to y, but x is between x1 and x2, then it is nothing but f x y of x2y minus f x y of x1y. Let us find out this how it can be proved. So, it is saying that suppose let us consider x1 less than x2. If x1 is equal to x2, it is trivial cases. So, it will be so there is nothing to prove, but x1 less than x2 f x y of x less than equal to x2 greater than x1 comma sorry, we want to find probability. Probability x1 is less than x2 and y is any other real number and x1 is also 2 real number, x1 is less than x2. Probability that x less than equal to x2 greater than x1 and y less than equal to y. What will be this probability? So, this probability will be, so this is f x y of x2y minus f x y of x1y. So, whenever it was only univariate cases, it is nothing but f x of x2 minus f of x1, but here y also there. So, fixing y we can find out this probability. So, how we can prove this? This is, so now how this event we can represent x less than equal to, sorry, how this event. So, this probability actually nothing but if you can write probability that x less than equal to x2 greater than x1 comma y less than equal to y. What is the probability? This probability is nothing but intersection of two event x less than equal to x2 greater than x1 intersection y less than equal to y. Now, how this event? First of all, let us find out what is the event now. So, x1 less than x less than equal to x2, this set is nothing but all s satisfying this relationship x of s less than equal to x2 greater than x1. So, this is the set. Now, this set we can say, this set we can represent by s belongs to s such that. So, can we represent this x of s less than equal to x1 one set, sorry, x2 minus all s belongs to s such that x of s less than equal to x1. So, basically what is this? So, now we are talking about there is x1 and this is x2. Now, we want to find the probability that this random variable is taking value greater than x1 less than x2. So, we are saying that what is the probability or the event that random variable taking inside minus infinity to x1 minus minus infinity to x2 all the value and minus infinity to x1, then this is the interval actually we are finding. So, this is nothing but x less than equal to x2 minus x less than equal to x1. So, this event we can write in this way. Now, this is same as, now if this is true, if you take any intersection with this both the set, then this will be same. So, hence we can say that x1 less than x less than equal to x2, if you take intersection with any set y, this can be represented as x less than equal to x2 intersection y less than equal to y, because if this minus this is the set and you are taking intersection both the cases same. So, then it will be, this should be equal to minus this, similarly it will be found x less than equal to x1 intersection y less than equal to y. So, that actually how we can show it. So, it is using distributive property also you can show, because this can be represented as x less than equal to x 2 minus x less than equal to x 1 less than equal to x 1 intersection with y less than equal to y, and then using distribution property like this x less than equal to x 2 intersection with y less than equal to y minus x less than equal to x 1 intersection y less than equal to y. So, any of this way you can you have understood, or if you use a Venn diagram also, so that also you can find. So, suppose this is x less than equal to x 2, and actually 1 minute, there is some other importance also. See, this is nothing but x less than equal to x 2 is subset of x less than equal to x 1. So, that minus part is nothing but this. Now, if you take intersection of any other y less than equal to y, so this is what will be that. So, this is nothing but this intersection part is nothing but this part only, this part. So, now how we will find that? This is in this set intersection with this set. So, this minus set, this is the intersection, and then this set the intersection with this set. So, then we will get whole set, this is also included. So, this minus this we will get this set. So, that is actually explained here. So, one of the way you can see this is true, and also this set will be basically this part will be subset of this part. So, sorry, this part will be, this set will be subset of this set. So, basically this whole set will be subset of this set, sorry, this set is subset of this whole set. So, then we have this we have theorem 1.1, we have already proved that whenever one set is subset of, suppose A is subset of B, then we know that probability of A is less than equal to probability of B. So, that we will apply here. So, sorry, and not only that, probability of B minus A in theorem 1 we have proved that this is nothing but probability of B minus probability of A. So, that we will apply here. So, now what we got? So, this, let us write down this probability. So, we started from here. So, then what we will get? So, what we will get? Probability that x less than equal to x 2 greater than x 1 comma y less than equal to y. This is nothing but probability that first we will write x 2 greater than x 1, this event intersection y less than equal to y, this event we have represented by x less than equal to x 2 intersection y less than equal to y minus x less than equal to x 1 intersection y less than equal to y. That we have already shown, just now we have shown it. So, then because this set is subset of this set, by theorem 1.1 we can prove, we can x less than equal to x 2, this probability of this minus probability of x less than equal to x 1 intersection y less than equal to y, probability of B minus probability of A. So, this is nothing but less than equal to x 2 comma y less than equal to y minus this is nothing but x less than equal to x 1 comma y less than equal to y. So, this is by definition of cumulative distribution function, joint cumulative distribution function f x y of x 2 y minus this is nothing but f x y of x 1 y. So, that we have proved. So, this is one of the properties we wanted to prove. So, this is the proof. So, now this is, so these things we have already proved. Now, these things similarly you can prove this. So, what is this? So, this says that this is the other coordinates actually, x is any real number and y 1 and y 2 two real numbers such that y 1 less than y 2, then probability that x less than equal to x comma y less than equal to y 2 greater than y 1, this probability will be nothing but we can show that this is f x y of x y 1 minus f x y of x y 2. So, sorry this will be f x y of y 2 minus f x y of x y 1. So, this is very similarly you can prove that. Also you can graphically it is you can represent it, how it can be done. So, how, let us in the next page let us see that. So, what we are saying, for x belongs to any real number and y 1 and y 2 two real number such that y 1 less than y 2. Then we can show that this is then probability that x less than equal to x comma y less than equal to y 2 greater than y 1, this can be represented as f x y of x y 2 minus f x y of x y 1. So, that is we have written just before. Yeah.